What about ridge characteristics? Fingerprints are compared by noting the ridge characteristics and flow directions in two prints and determining whether or not they match. The similarity in the structure of individual ridges may also be considered. Additionally, clarity and uniqueness of the ridge arrangement can be factors. Well, what are we looking at as far as ridge characteristics? Well, there are three main ridge characteristics that we need to be aware of: the ending ridge, the bifurcation, and the dot. So what are they? Let's look at the ending ridge. This is pretty much self-explanatory. It is the point at which a ridge ends. Now, a little over inking or under inking on the known print, or a little over or under development on the latent print, can slightly extend or shorten this point. The second characteristic is the bifurcation. This is the point where a ridge divides. As with the ending ridge, differences in inking of known prints and development of latent prints can slightly affect or alter their appearance. And then the third characteristic is the dot. The dot is a small ridge with no direction. It is generally circular in appearance, but it can have irregular edges. To be considered a true characteristic, it must be as wide as the surrounding ridges. So in other words, the width has to be pretty much the same width as a ridge that's nearby. Now you can see some ridges look a little smaller than others, and it's more because of the inking or the dusting that we get that than the actual characteristics of the ridges. Ridges are pretty uniform one to the next. So this should be about the same width as that. Do not expect a latent fingerprint and its matching known fingerprint to be exact duplicate copies of each other. Pressure, surface type, background material, along with under and over inking and or development can alter the microscopic appearance of the ridges. And we actually talked about that as we first started out this evening in clarity. Some claim that there are additional characteristics such as the island, short ending ridge, and others. These are not individual characteristics, but combinations of the three main characteristics. They would be more properly referred to as ridge formations. All right. So ridge characteristics, we have the three. If you hear some of these other things, they may be referred to as ridge formations. Fingerprint characteristics are also known as ridge characteristics. Points of identity, Galton's details, minutia, and what I prefer to use is the term points. These are fingerprint characteristics or points, mainly because it's easy to say and doesn't sound too fancy like minutia. You know, when you're talking in court and there's a jury, you want to keep your explanations and your terminology more toward layman terms as much as you can and still be scientifically accurate. That the average fully recorded known fingerprint, either ink or live scan, contains an average of 75 to 150 points. If you have a fully recorded, so you have a lot of finger detail, you're going to have a lot of points, 75 to 150. The reason for the wide range number is that some patterns, such as the plain and tinted arch, tend to have fewer points than a whirl or a loop pattern. They'll have more points. But that kind of gives you an idea of what could be there. And we have to find some of them in order to make our identification. Well, that being said, how many points do we actually need? There is no international standard for the number of points of identification required for a match between two fingerprints. Now, if you look at some other countries, you will find that some countries do have requirements. The last time I checked, the United Kingdom requires a minimum of 16 points for an identification. Australia requires 12 points. However, in the United States, there has never been a legal requirement for a minimum number of matching points, though up until about 1943, some publications like the FBI's Science of Fingerprints cited 12 points, but it was never really a requirement. So there's never really been a requirement. But you know, people think that. They think you got to have 12 points. I Googled how many points needed for an identification, and it came up with 12. It's wrong. So in the United States judicial system, there is no legal standard for the minimum number of points needed to identify one fingerprint against another. However, some law enforcement agencies may and often do impose a minimum standard for their personnel. So the question becomes, if there's no absolute standard as to the number of points, how do I know when I have enough to identify the fingerprint? A general, loose working guide, 8 points of identity, lying in the same relative position in 2 fingerprints are generally sufficient to identify one against another. Now, that doesn't mean that 8 points constitute a minimum standard. Some latent prints may require more points and some perhaps slightly less. Also, fingerprints are not usually identified based on the number of points alone. As previously mentioned, other factors are also considered. Ridges must be flowing in the same general direction. The ridge structure may at times be examined for things like ridge thickness, pore location, and edge sharpness. The clarity of the print and the uniqueness of the ridge arrangement can be significant. Ridge flow direction. So ridges have a directional flow. If you remember in classification, ulnar and radial loops had different directions in their ridge flow. When comparing latent fingerprints, the terms ulnar and radial in reference to loops are not used. If it can be determined that a latent print is a loop, it's said to either be flowing to the right or to the left. Because until a fingerprint is identified, you do not know for certain on what hand that latent fingerprint appeared. Therefore, you can't determine if it's ulnar or radial. Although loops are the most obvious example, all pattern types have ridge flow directions. Ridge flow direction is a class characteristic. That is, a fingerprint cannot be identified by this factor alone. There are only 8 fingerprint pattern types, although ridge flow direction can vary within some of these types. Therefore, latent and known fingerprints that are not identical with each other can be the same pattern type and have the same ridge flow direction. Again, it's a class characteristic, ridge flow. So you could say these two do have the same ridge flow, but then when you go to the next step, the second level, you're going to say, oh, they had the same ridge flow, but they do not have the same individual ridge paths. So let's look at an example here. Notice that the differences in the ridge flow direction in these 3 fingerprints. When examining a latent fingerprint, attempt to determine its pattern type by the flow of ridges. This will be easy in some instances, difficult in others, and impossible in some cases. If it can be determined that the latent print is a left slope loop with at least 10 ridge counts, then all the whorls, arches, right slope loops, and left slope loops with ridge counts of 8 or less, don't cut it too close, appearing in the known prints can be immediately eliminated. So this is where your knowledge of classification is going to be helpful in the comparison process. So left slope loops can't be identical with right slope loops, or with any whorls, or with any arches. Whorls cannot be identified with loops or arches. They would all be different in their ridge flow direction. Notice how the ridge flow in different pattern types. So we're looking at these. Here we have a right flowing loop. Yes. Here we have a whorl, and here we have an arch. So we can see right now that these are all dissimilar because their ridge flow patterns are different, the ridge flow directions. Now, if we look at the image on the left here, that's a fingerprint in which much of the pattern is not visible. But there is valuable information that can be determined about this fingerprint if we know about classification. First, even though only one delta is visible, it has to be a whorl due to the ridge flow direction near the center, the circular flow. So we can look at that and say, that's a whorl, even though we don't have more detail than that. We don't see the other delta. We can still say that's a whorl. All right, so we can deal with these smaller pieces. And when you get latents from a crime scene, you're not going to get a beautiful rolled edge to edge kind of result. You're going to get fingertips, you're going to get small portions of the fingertip, of the finger itself. You're going to get all kinds of stuff, and they're not going to be large in most cases. So you're dealing with a portion of the print. As I said, because we have a delta and we have that circular pattern, we can say it's a whorl. All right, and then we eliminate any other prints that we're trying to compare to that are not whorls. Boom, they're out. That helps us to narrow down very quickly. Additionally, this whorl has to be one with an inner tracing. Why? Because if we do our tracing, it's going to be inside wherever that delta is, and it's 3 or more ridges inside definitely. So we know it's a whorl with an inner tracing. So when we look at our known prints, do I have any whorls with inner tracings? Here's one. Now I can look at this one and exclude all the rest. Then we have the structure of ridges. So what we're doing now is we're looking at the third level detail, right? Ridge appearance. The structure of individual ridges involves its 3 parts, which are the edges, pores, and skin cells. A close inspection of a single ridge can disclose valuable information. So keep in mind that ridges can vary in width, height, and overall texture. In other words, ridges look different one to another. The shape, size, and location of the pores and the contours and shapes along the edge of individual ridges will fall into this category. So let's look at the pores first. Pores are funnel-shaped holes or openings along the friction ridges of the hands and feet. They appear as white dots along the black ridges. So we have here these white dots. So that's a pore, there's a pore, and so forth. All right. Now, a pore can vary in shape and size. They can be round, oval, elliptical, square, triangular. They can be different sizes from 88 1,000ths to 200 1,000ths millimeter. The pores average approximately 2,700 per square inch on the palms of the hand and on the soles and toes of the feet. Pores are generally found to be located along the midline of the friction ridges. However, occasionally they can appear on the extreme edge. When the pore appears on the edge, it will in many cases resemble a notch or open pocket. As we see here, that would be a pore, but it appears in that fashion. Now, you're not always going to see pores. They're not always visible in either the latent or the known. They can be filled in by ink. Too much ink, you're not going to see pores. If you've over dusted your print, or whoever did the latent lift, they use too much powder, the pores can be filled in with powder. So how does this work? Well, I'll tell you. Perspiration is discharged through the pores and flows over the ridges, causing them to become moist. And when an object is touched, an outline in moisture corresponding to the ridges may be left. And that's the latent print. Most of our latent prints are made up of moisture and oils. And so you have these pores that are exuding the perspiration. The developer reacts with this moisture and or its ingredients. It is only natural that the greatest amount of moisture would be found around the pore areas. Also, when the latent print begins to age, the first area to dry out would be the areas between the pores. Then when a developer is applied to these ridges, more will cling or tend to react with the greater amount of sweat still present around the pores and less on the spaces between them. So when you have an older print where it's been, a lot of the moisture is evaporated, this can give the latent an uneven appearance. And it's one reason that the latent ridge will not appear exactly as the ridge on the known print. Sometimes you can have instances where there's too much moisture on the latent print and the ridges will appear thicker than those of the known print. So these are some things that go to show us that your evidence print lifted at the scene is not going to be an exact duplicate copy of your known print. Structure of ridges. Next is the edges of these friction ridges. They're not smooth, but they have contours and shapes. So as you look along the edge of these ridges, you can see they're all kind of jaggedy and bumpy. Well, that's the way they are when you examine them under magnification. When we just look at our fingertips, we can't see that. But when you magnify it, you will see that these ridges do have contours and shapes. These contours and shapes, when we can see them, are unique, like pores, and can be taken into consideration when comparing and identifying prints. Edge contours and shapes can be affected by various factors such as ink, developing agents, foreign material, pressure. That's why it's difficult to have an edge match on an individual ridge in two prints on the same finger. While on a purely scientific basis, there is a possibility of identifying a latent print by edge and pore shapes and the arrangements of a single ridge. That's not very practical. These edges can be helpful in making our identification. How can we actually use this when we're trying to describe things? Well, if you're in court and you are going to testify that you have identified this latent print to the defendant, you're going to want to have a chart, you're going to want to have an illustration, you're going to want to have, we've all seen these in books and on TV, the latent enlarged and then the known rolled print from the defendant next to it, and you have the numbers off of it. I should get one of those, and it's the points. Well, then you can also have an enlargement of the structures that you want to talk about as well. So you say, I have these 20 points. By the way, I like getting 20 points. Now, let me go back to the points for just a second. Sorry. We said that there's no minimum number. So how many do you need? Well, Gary says you need to have probably at least 8, and then other stuff can be part of it. Well, what I like to do, because there are a lot of points normally there, is keep going until I have 20. 20 just seems like a magical number to me. You know, everybody has heard 12 on TV. So the jury has probably heard, you've got to have 12 points. So I prefer not to go in with less than 12, because then you have to really educate the jury, explain to them that if you've heard that on TV, that is not a requirement. And this is why this is an identification. But let's say that you have more than 12. If you have 20 and they're thinking 12 is necessary, wow, that's a whole lot. And many times you can have a lot more than 20. So I like to go for 20 points, and then you have your diagram with all those numbers. Now, some people think that's a little overkill, and why are you wasting your time with all that? But, you know, it's important to make sure the jury believes that your testimony is bulletproof, that your examination is 100% valid, that your identification is true. Uniqueness and ridge arrangement. This part, uniqueness and ridge arrangement, this is subjective. What's unique to one examiner may cause another examiner to say, oh, I've seen that a dozen times. So when we're talking about this arrangement is unique, it is subjective. And if you're just starting to analyze and compare prints, determining what is unique is difficult, if not impossible. After all, you have not looked at a large number of prints and their ridge arrangements, and you have no way of determining what is rare or unusual. So don't even consider talking about the uniqueness of your fingerprint as a factor until you've looked at a large number of fingerprints, which could take you a considerable length of time. But in time, you're going to come to understand what is and what is not unique. So we're not going to get into this now. This is something that you would come up with on your own later and through your education process and experience. So remember, fingerprints cannot be identified by ridge flow direction alone due to such variables as pressure, ink, foreign material, excessive or lack of moisture on individual ridges, etc. It's extremely difficult to identify a fingerprint just by this ridge structure alone, like the pores and so forth. However, fingerprints can be identified by ridge characteristics, points, as long as they are present in sufficient numbers and in the same relative position to each other. In most instances, these factors will be present, but as a novice in fingerprint comparison, you will need to concentrate on ridge points. Other means of identifying latent fingerprints will come naturally as you do more comparisons. We're going to talk about analyzing latent prints. We're in the topic of comparisons, so I would say this is where you get down to the actual comparison, but let's take a look. The first step when examining latent print is to determine if it's of value or not. So in the ACE-V, we've already learned that's the analysis step. This term refers to the print being of sufficient clarity and containing a sufficient number of points to allow it to be compared against the corresponding area in a known print and to positively determine if it was or was not made by the same finger. Now, when you are analyzing or evaluating the latent print, your evidence print, you may or may not have known prints for comparison at that time. It may be the case in which suspects have not yet been developed. That is why factors such as unity in ridge flow direction and similarities in individual ridge structure cannot be considered until you have a known print with which to compare the latent print. Now, there's two ways to get that. One, you already know who your suspect is, and you can get a hold of a 10 print card from that individual. The other would be to do an APHIS search, and the APHIS search brings up an individual as a leading candidate. Then you would be able to make your comparison. But often we're just at a standstill. We have the latent prints. Nowadays we can put that into APHIS and we get nothing in return that matches, and we're just waiting. There can at times be an instant with a latent or known print in which the ridge appears to end, and a very short distance later, directly in line with it, another ridge appears. So right in here, where the end of that arrow is, there's a little space. But if you look, the ridge, there's a break, but the ridge takes up immediately after that little space, and it's totally in line. Of course, it's curving, but it's in line. All right. So what does that tell us? Well, you must attempt to determine if these are two separate points or merely a place on the ridge where the ink or developing agent did not adhere. Now, if we look at the other one, we'll see a difference. But here we have a break, but they don't appear to line up. So you've got to decide, is this actually a point or not? And if you're not sure it is, then don't use it. Now, if it's exactly the same on the whatever you're comparing to, then okay, we're good. But again, let's say that on your latent, it shows that little break, but on the known, there's no break at all. That's when you have to decide, is this just a continuation that didn't get picked up by the ink or the powder, or what is it? Notice the ridge endings, bifurcation, and dots. If you observe the ridges flowing on each side of these points, you will notice that in many instances, they widen slightly to accommodate these characteristics. So when you have a bifurcation, the ridge tends to widen slightly. This can be a clue to a true ridge ending, bifurcation, or dot. In the image on the right, that looks more like a true break than the one in the image on the left. This manner of ridges that flow on either side of the point widening to accommodate the point is a tendency that may not occur all the time. If the same break appears in the same relative position on both latent and known prints, they can be counted as points regardless of if there's any widening or not. All right, now we're going to talk about relative position. Again, we're looking at our first steps in analyzing or comparing a fingerprint. Relative position is a term that is frequently used when describing the identification of a fingerprint. It means that the ridge characteristics or points in question are positioned to each other in the same corresponding manner or relationship. If we look at these first two, these are simplified drawings of perhaps it could be ridges. It's of course not, just to give us an idea of what we're looking at. All right. So if you look at the first two, they are identical. There are the same number of ridges, and the fifth one from the top has both ends of the ridge visible. So we have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And this one, it's a short one that we can see both ends. We can also see the approximate lengths of them. Now remember, inking and dusting, the ridges can appear to be a little longer or a little shorter, but we're getting the same kind of pattern here. However, if we look at the last one here, everything is the same except we have an extra ridge in here. If this were a true latent fingerprint, it would be extremely difficult to explain the extra ridge. And all it takes is one unexplainable point of dissimilarity between two fingerprints for them to be considered non-identical. Remember, the key word is unexplainable. So what could be explainable? Well, you could have a double impression. We're going to talk about that later, where one fingerprint's placed on top of another. Maybe a little slippage when the fingerprint was laid down. But it's very difficult to account for an extra ridge. So if you can't explain it, then those two are not going to be identical. They're non-identical. All right. Now, if we look at these three, they're all different. A few of the ridges here, may appear to be in the same position, but if we look carefully, we can see they're all different. All right. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. All right. So this one's out. This one, we can see a ridge ending here, both sides up here. So obviously these would not be identical. So how does this all work when we're comparing fingerprints? First of all, when you are comparing fingerprints, the recommendation is to begin with the easiest comparisons. So compare the latent fingerprints that are the clearest with an abundance of points or where the location is apparent. Get those, if any, out of the way first. So you have your known card and you've got your latents. Pick the ones that are the easiest to do first. The ones that has the most detail, have a lot of points. In other words, if I had several to choose from, and some of them were those fingertips we saw earlier, those little tiny pieces, I wouldn't start with those. I would start with the ones that look like I'm going to have the most success with and get those out of the way first. We're going to look for focal points. So what could be a focal point? Well, the delta or the core, those help us to focus on a portion of the fingerprint. So that's a good focal point. It directs you to the exact location of those features on the latent print. So the presence of a focal point can yield invaluable information about the print. Now, if no focal points are visible, the shape of the latent print, creases, and other information will have to be considered. And we're going to discuss that a little bit later. What you want to do is pick out 2 or 3 points in close proximity to one another. So we're going to look for similar points that are in the same relationship and position to each other and flowing in the same direction. It is possible to find 2, 3, or possibly a couple more points in both the known and the latent fingerprint that look the same. But when you expand your search for additional matching points, none appear, or you see an unexplainable dissimilar point. Well, if that happens, then fine, the print is not identical. Go on to the next comparison. However, when you begin counting out from the starting points and begin to find additional points that are alike and in the same relative position, then we're on our way. The latent fingerprint becomes identical with the known fingerprint when the examiner reaches that conclusion. We're going to pick out 1 or 2 points in close proximity to each other. So this illustrates a latent fingerprint here on the left. I had to enlarge it, so it's a little blurry, I'm sorry. But that's an enlargement of the delta area showing a typical starting point. So we have a delta area, and then we have a cluster of 3 points in close proximity to one another. So here I see the delta, and I say, okay, I've got the delta in my latent, and I've got area up here. I look at the ridge flow. Okay, I've got this oriented correctly. So let me find 3 points that are close to each other, in close proximity to each other. 1, 2, 3. All right, I found those 3 above the delta. Now let me look over here. And if I find those 1, 2, 3 in that same general area, all right, I'm going to keep going. And then I look for other areas. I expand out from that. But that's a good way to get started. You find a focal point, and you find that focal point in both the latent and the known, and then you move to an area near that is still in both, where you've got 3 points right next to each other, and you go boom, 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 I got it. And then you just develop it further. All right, now we're still comparing these fingerprints. And we need to talk about proper orientation. When beginning to compare a latent print, you have to have it in its proper orientation. Sometimes this is difficult to figure out. At times, it can't even be determined, which means the latent print must be compared in several positions. You have to keep moving it around. A lot of time is wasted comparing a print upside down or oriented sideways. You can speed up your comparison time if you can avoid that by orienting it properly. So how do we try to get it oriented properly and avoid all that extra work? It could be by observing, if it's there, the shape of the latent, the position of focal points, and any of the creases, joint creases, and so forth. Here are some tips. Ridges on the top of a fingerprint tend to flatten out and appear thicker, like they are in this picture on the left. So notice how the ridges seem to look thicker. All right, so that could be a clue. Ridges on the extreme edges begin to fade. So you may see that. So once you have handled a lot of these prints, you start to see things that give you clues as to what direction it is. When I look at this, I say, well, that's got to be the top. Now in this picture, we would want to place this in its proper orientation. Well, it looks sideways, doesn't it? It looks like it might be a palm print, but this is actually a fingerprint that's been enlarged, all right? First, notice the white space running through the center of the print. This is a joint crease. This indicates that the latent is lying sideways, so it needs to be turned right side up. But which way is up? Well, as it appears in this image here, look at the ridges on the right. They appear to be bending to form the pattern area, and the bottom area of a delta is visible. Delta, all right? The ridges on the left side appear to be running at straight angles, and they appear to be thinner or less distinct than those on the right. This would indicate that the proper orientation of the latent would be to rotate it counterclockwise 1/4 turn, with those bending ridges forming the bottom of the pattern. So we would turn this. The joint crease can act like a focal point. It can indicate a location at which you begin your comparison. You must be very careful, however. Joint creases can expand and contract. If the joint crease is narrower on one print, it can show points that do not appear on the other. And if the crease is wider, it can obscure some points. So if you're looking for points along the crease, that is not going to always be reliable, because that can expand and contract depending on how the print was laid down. Now let's look at simultaneous impressions. Simultaneous latent fingerprints are left when two or more fingers adjacent to each other touch an object. The most common combinations are the index, middle, and ring, index and middle, or middle and ring. When this occurs, it can be of great assistance when determining which fingers to compare. Care must be taken when objects are handled. Latent fingerprints can be deposited in such a manner so as to appear as simultaneous when in fact they are not. So when you see like 3 of them like this, especially when the height differences are like this, it's pretty good chance that this is simultaneously put down by 3 fingers on the same hand, from the same hand. But just because there's 3 fingerprints next to each other doesn't mean that's the case. It could be 3 different touchings of the same object, and it's just a coincidence they ended up that way. And if you look at your hand, you can see that the fingers are of different heights, or lengths, I should say. Now, another thing that can be different, though, is let's say that the person touching has their hand cupped. Now, all your fingertips are even. No longer do you have what appears to be one long and two that are a little shorter and one even shorter. Now they all appear to be the same length. So if someone touches something in that manner, you could have simultaneous impressions that are straight across. When you can get these three in a row all matching the fingerprint card, oh, that's golden. All right. Then we have in this comparison process, when we compare latent fingerprints, pattern tendencies. This means the following examples do not hold true in every instance. Knowledge of pattern tendencies just tells you where to look first. The shape and flow of fingerprint patterns when they appear in the latent fingerprint can indicate on which hand at times, and at times which individual fingerprint they most often appear. Okay, so pattern tendencies. A whirl with a counterclockwise twist, like this one on the left here, is common on fingers of the right hand. Whirls with a clockwise twist are most often found on the left hand. All right. That can be something that helps you, a place to look. As discussed before, right slope loops are most often on fingers of the right hand, and left slope loops are found most often in the left hand. Not always, but that's the tendency. Thumbs tend to be wider than the fingers, with less chance of a lower joint appearing in your rolled impression or in your latent print. So these are some tendencies that you pick up as you work along through this, and they can be helpful. All right, so let's look at this. Observe the ascending loop on the double loop whirl. Okay, so we're looking at the descending loop. So like this part here and that part there, the part that's coming down. This is ascending, this is descending. In many whirls, even if not a double loop, they have a right or left general slope. Sloping to the right will usually indicate that the examiner will compare the fingerprints with the right hand first. A left sloping whirl will be just the opposite. All right. So if you have a right ascending loop in a double loop whirl, look at the fingers at the right hand first. And we're going to talk about the tips of the fingers for a moment. We got to see some other examples of tips of fingers, and I showed you how there was detail there using first, second, and third level detail. First level is ridge flow, second level is the path of individual ridges, and the third level is ridge appearance. These latent prints, these tips of fingers, are often the most difficult to compare. In many instances, only a portion of the corresponding area will appear on the fingerprint card, or at times none at all. No focal points are visible, so finding the correct area to compare is often difficult. There'll be times when no comparisons are possible. If the latent print is from the extreme tip, side, or lower joint area, and those are not recorded on the fingerprint card, there's nothing to do. You're not going to get any kind of match. Now, tips are not hard to recognize. If they're deposited simultaneously, as you see in this picture on the screen, the latent fingerprint from the extreme tip area will be somewhat rounded in appearance. The ridges near the top will tend to flatten out. And they usually appear to be a little thicker up here as well. The ridges below the extreme tip area will begin to exhibit more curvature as the pattern area is approached. The ridges in the whirl or loop will be bending to form their respective patterns. The exception is the plane and at times the tinted arch, which generally exhibits no severe curving of the ridges, even in the pattern area. So that's a little bit about the tips there. Let's look at the sides of the fingers for a moment. The side area that we see here in this image on the left is fairly obvious in as much as the crease at the bottom of the end of the joint is visible. So we see a crease here. Also, I can see a delta. So this tells me that this is the distal end of the finger, of the phalange. The examination reveals that a focal point, the delta, is clearly visible. That's what I just said. The flow of ridges indicates the pattern is on the right side. Therefore, this fingerprint would be from the left side. All right, if your delta is here and the ridges are going that direction, this side over here is going to be the part you really wished you had. This is the side of the finger. Now, the middle finger here, not necessarily the middle finger, the middle picture, I don't know if that's a middle finger or not, illustrates a fingerprint on the right side. Again, we've got ridge flow, gives a pattern. We see a delta that's halfway up the fingerprint on the left side. And we have the crease. So now we know this is the right side of the fingerprint. That the pattern is to the left. All right. And then this one shows the far left of the fingerprint, the far left side of the fingerprint. The ridges, as they approach the extreme side, begin to fade or break apart as they near the area where they cease to exist. It is not unusual to see a latent print this far out on the side because the ridges generally go as far as the fingernail before they disappear. If you look at your fingers with a magnifying glass, you'll see your ridges go around the side of your finger like that. All right. Anyway, so that's the sides of fingers. And this is for identification purposes. It helps you to then say, what can I do with this? Here's my suspect's prints. Do I have anything that shows the sides? And then you just say, I got to move on from this. It might be, though, when you're looking at this one, I've got a delta and I've got this here. Let me look at the print and see if I can get some points out of this. And you just may do it. Remember the fingertip picture? You're going to, you don't need a whole lot as long as there's some on the fingerprint card. And definitely your fingerprint card should have at least this part over here. All right, lower joints. These are 2 joint areas in thumbs and 3 in the remaining fingers. They are referred to as the end joint, where the pattern is located, the middle or second joint, directly below the end joint, and the third joint, so from the top down. In the case of thumbs, it's the end and lower joint. These joint areas have technical names. The finger is the phalange, and the 3 joint areas are termed distal, medial, and proximal. Distal is the furthest away from the body. Proximal is the closest. Medial will be in between. In some instances, when a lower joint is deposited as a latent fingerprint, a portion of the end of the joint will be visible. This can greatly aid the examiner in determining which fingers to consider when making comparisons against known fingerprints. In this instance, the delta area is visible in the end joint on the right side of the fingerprint. The ridge flow would dictate the pattern is to the left. Okay, right in here, left. Now, where can you find this? Well, sometimes in the 10 print card, when the simultaneous prints are put down, the 2 hands, the 4 fingers, excluding the thumb, are put straight down at once, you will get portions of the finger beyond where the normal fingerprint is rolled. As objects are handled, it's not unusual for latent prints to be deposited on each other. And this can obscure some latent prints, but not always. In many cases, it's possible to identify double impressions. It's a matter of closely inspecting the latent prints and attempting to separate one latent print from another. And this is where your knowledge of ridge flow can be helpful. Now, double impressions that are like this, where one is vertical and the other one's horizontal, those are easier to separate out than two that are in the same line. That's going to be very difficult. Palm prints. All right. So palm prints, like fingerprints, have certain predictable tendencies that can be very helpful when comparing. So we don't just compare the fingertips, but we can also compare ridge detail from the fingers and from the palms, as well as the soles of your feet and your toes. In the interdigital area, remember the interdigital area here? Notice the presence of delta formations and loops. Okay, that's what we're getting at. So you're going to see delta formations and loops in this area. And they can be mistaken for a fingerprint. So here's one here that this is actually part of a palm print. And you're looking at that saying, I got a good fingerprint here. So sometimes we get a little bit fooled. Palm prints have a direction of flow. For instance, if you examine the area of the palm underneath the middle and ring fingers. So if you look under these fingertips here, you will see that those ridges flow in certain directions. In the right palm, they may flow to the right. In the left palm, they flow to the left. That's what they tend to do. If the latent palm print appeared as either of these examples, you'd be able to tell which palm they came from. So this one is the right palm, and this one is the left palm. The right palm, the ridges tend to flow to the right, and in the left palm, they tend to flow to the left. Scars and creases. A permanent scar is wider and irregular than with the ridges bending away from each other on a scar. So notice here that the ridges, as opposed to this where the ridges are kind of still lined up, on a scar, they can bend away from each other where the scar line is. So this would be a scar. A temporary incision or a temporary scar, it's going to heal and may not appear later. So we don't want to consider scars of either type as a point. Scars, even permanent ones, can change the appearance over time. But if it's there, go back and compare it as if the scar was absent. Creases tend to be irregular in shape with the ridges not bending away. So these are just creases. Scars tend to be a little more lineal, while creases are irregular in shape. Creases can be used to locate an area, but don't depend on them. They can change in appearance and at times not appear at all.